Hi everyone, this is Wei Xiang saying hi from Melbourne, Australia, and welcome to the EAI ICON 2020 conference. My name is Wei Xiang, and I'm the Cisco Research Chair of AI and Internet of Things, and I also director the Cisco Center for AI and IoT based out of the La Trobe University. Today, my keynote topic is about artificial intelligence, Internet of Underwater Things, opportunities, applications, and challenges. So I'll be first, today my talk's content is, I'll first talk about what is Internet of Things, and is a term, IoT is a term that a lot of people are familiar with. Yeah, but there's still a lot of confusion out there, particularly what the things are. Yeah, and then I'll talk about, why, we say AI and IoT, we can't really separate them, So I'm going to share my perspective as to how AI and IoT work together. And then I'll talk about some of my past work on AIoT at my previous university, James Cook University, and also my current university, La Trobe University. And then I use the Great Barrier Reef, one of the greatest treasure on Earth, as a user example to show you how AIoT technology can be applied to the marine environment. In the last, before we conclude the talk, I want to share with you one of our most recent work, the proposal of a novel bi-directional recursive encoder and decoder network. So this is a new neural network architect we propose, and that can be used to impute missing data, both missing data and also predict the future data in multivariate time series sensory networks, which are very applicable to the marine environment. So first of all, let's talk about AI, the history of AI. So AI has been a buzzword for quite a few years. It's been showing remarkable strengths, performance in almost every single vertical industry. But AI as a term, as a technology or term, is nothing new. It's actually started a long time ago. Yeah, back in 1940. Yeah, it was used to very firstly, it was known as stemmed from a concept called electronic brain back in 1940. Yeah, and then over the past few decades, AI has been going through quite a few cycles. Yeah, it had its own so-called back in 1960s, the so-called golden age, and also suffered from so-called dark age in 1970. And relatively recently, around 2006, the advent of deep neural networks is actually showed remarkable performance. And engineers and researchers, scientists find out if we can train a multiple layers, so-called deep neural networks, if we train them with good quality data, a lot of them, relatively high quality of them, and we can get a very exceptional performance. We don't know why, but turn out sometimes even better than what humans can do. For example, in the computer vision area, in the facial detection, the most current deep neural networks can even outperform human eyes. So that's been a history about AI. I assume everyone is kind of familiar. On the other hand, Internet of Things is equally a very popular technology. In the last decade. But again, similar to AI, Internet of Things is also nothing new. It was used to be more than 20 years ago. It used to be so-called wireless sensor networks. And back then, that's where, the engineers, the scientists are using the so-called, the scientific gadgets, the so-called sensors device, primarily used them to collect scientific data, like temperature, humidity, etc. But when time goes on, those so-called things or sensors are getting clever, and also getting ubiquitous connection. So they're not just able to collecting the data, but also they can become smart. They can making decisions on behalf of humans. For example, like a coffee machine, a smart coffee machine. When someone approach a coffee machine, yeah, a smart one, someone knows, yeah, this guy probably like a latte, yeah, so pour you automatically a cup of latte. When another person approaches the same smart machine, yeah, the machine can detect the other person might like a cappuccino, for example, and pour different cup of cafe. So when things become smarter, and and that embrace the so-called concept of Internet of Things. So what exactly is Internet of Things? And particularly, during my working experience, and particularly when I interacted with our students, and I was thinking one of the most common questions is what are things? Yeah. So how do we define technically what's Internet of Things? And different people has different their own favorite definition. And I'm going to share with you mine. From my perspective, I think Internet of Things is actually a data-driven ecosystem. Yeah, it's not a particularly technology. It's an entire ecosystem that is powered by data-driven. We can divide that into three layers. The bottom layer is so-called data acquisition, and that's where we use sensors, and collect all types of data. So this days almost for every type of physical data, and be it like temperature, humidity, acoustic information, gas acceleration, water leak, position, proximity, vision, anything you can name of. There's almost, off the shelf, sometimes a specialized sensor corresponding physical sensor that we can record that particular type of data. So this is the bottom layer, so-called data acquisition. And then the middle layer is so-called data communication. So because sensors are usually deployed out in the field. So when the sensor collects the data from the field, the data will be useless if the data just sits on the sensor going nowhere. So data communication is very important in terms of getting the data out of the sensor and data deploying the field and onto the cloud. Used to be the most popular destination for sensory data is we send the data to the cloud. But most recently, and people find out probably, not every bit of data is useful. Sometimes we can try to reduce the amount of the data we send over the cloud. And also we can reduce by sending less data, we can reduce the so-called latency. So rather than sending every possible data, collect the data to the cloud, we can process the data straight away on the edge. So this is the so-called edge computing or fog computing. And this processing is coming closer to nodes. Sometimes when the sensor nodes become relatively powerful, so some node can directly processing data, right on the nodes. So it doesn't have to be always cloud computing. It can be edge computing or even node computing. But nevertheless, data communication is very important. Whether wherever we process data, the raw data can be processed anywhere, but the result of the data needs to be still needs to be sent over to the clouds. So this is what happened, in the last a few decades, when it comes to data communication. So we're coming through the age 1G, 2G, 3G, 4G, 5G. Now 5G has already been standardized, and one of the unique characteristics for 5G communication is that unlike the previous 1G to 4G, they will design primarily for humans to use. People like you and me to use 1G to 4G in the last 3 decades or 4 decades. But 5G is first time in human history. It's not only designed for human use, but also more importantly, they're designed for sensors to use for specifically for sensor communication, because 2 out of the 3 use a scenario of 5G communication to do with the sensor communication, like the user scenario of massive machine type communication, and that is concerned with relatively low rates, but massive number of IoT communication. But also there's a third category. It's called a low latency, ultra reliable IoT data communication. That's applicable to things like industrial 4.0 environments, or vehicle networks that will, the low latency and ultra reliability are specifically very, very important. Both of them can be considered as a special case scenarios of IoT. Now, the moving upwards, the top layer is called data analytics. So previous two layers, data acquisition and data communication, they are just means, they're not purposes. Because the previous two layers, collect the data and send the data onto the cloud. And but yeah, some people might think, oh, data, I heard a lot of people talking about data is, it's very useful. Data is king. Yeah, data is the most precious asset in 24th century. But I want to argue, yeah, data is actually useless. Data is absolutely useless unless we can turn data into information, knowledge, and insights. So this is the job of the top layer, yeah, so-called data analytics. So that's where the data being converted to the information, knowledge, and insights. So in this regard, we say the IoT is a data-driven ecosystem. If we have to put a number onto the relative importance of each layer, I would think 20% for data communication, data acquisition, and 20% for data communication, yeah, and 60% for data analytics, yeah. Those are just nominal figures to indicate the relative importance of different layers. All right, so and this is because of this the ecosystem. So, and that's why we say you can't really separate AI from IoT, because the top layer of the IoT ecosystem, the data analytics, and primarily use machine learning as a tool to analyze data. Yeah, and because, like as previously said, because the advent of multi-layer deep neural networks, so they provide very, very powerful tools for analyze IoT sensory data. So this is why we can't really separate AI and IoT. So, and also, when we combine AI and IoT, it's going to unleash a superpower because AIoT can be applied to virtually any industry, any vertical industry, like mining, yeah, transportation, agriculture, construction, vehicles, yeah. The number of IoT devices connected to the internet, connected to 5G, are going exponentially. Yeah, it's predicted by 2035, the number of 5G connected device, IoT device, will be over 5 trillion. Yeah, that's way more than the populations on Earth. Yeah, this means on average, each one of us will be having thousands, if not hundreds of thousands sensors. So that's the beauty of AIoT. Now, the future work for us is no longer out of reach. It's out there. It's very fast approaching. Yeah, so it's a smart word. So everywhere we go, yeah, every path we take, yeah, so there will be hundreds of thousands of sensors collecting data, watching the safety for us, and also some of them are smart enough and powerful enough to not only collect the data, but also making decisions for us without us having to know it. Yeah, so a classic example like autonomous vehicles, some of them can realize certain degrees of self-driving. So they can, relieve us, so they can drive rather than traditional vehicles. We human have to drive a traditional vehicle. Autonomous vehicle powered by AIoT technology can drive us and be safer and more economic. Now, this is what's happening in the industry, in the research side of AI IoT. So in the higher education, we kept asking us, what does this mean to universities around the world? And this was the answer I was trying to answer about 5 years ago when I first took up the position of IoT chair professor at the head of the Internet of Things discipline at James Cook University in Australia. Yeah. So back then, early 2016, we analyzed, the changing workforce in Australia. We realized, this is a map of Australia. Yeah, and the areas, with red, the red means those areas will be very much affected by automation and computerization. Yeah. So job will be lost very significantly in those red area. Yeah, if you look at the map on the left hand side, those areas around in Western Australia are being affected by a lot by AIoT, because that's where the mining heart of Australia is. The mining industry has transformed itself in recent years, highly automated, yeah, and highly intelligent. They're using a lot of sensors, a lot of the AI technology to do the mining. So those areas are being hit very hard in terms of job. Yeah. So we started asking a question about ourselves. If we kept teaching a student the traditional so-called majors, the STEM majors in our area, that's a EE or computer science, and they're going to find jobs in the future. Yeah, it is predicted in the next 5 years to 10 years, 40% of traditional jobs in Australia will be lost. Yeah, and this is when we did the prediction about 5 years ago, it was very, very bad. But these days, looking back forward in 5 years, it's become almost like reality. It's so close to us because Australia is such a small population and the labor cost is so high. So automation, computerization is the only way to go. Yeah. So this prompted us to respond to the new industrial revolution. So when I was took up the chair position and head of discipline at James Cook University, we proposed Australia's first Internet of Things undergraduate course at JCU's Cairns campus. The motivation was it's all about the jobs of the future. So we were trying to prepare our student for the jobs of the future. Yeah, rather than worry about your job, whether your job will be replaced by robotics. Yeah, I think the best strategy is because there's no chance a human can compete with a robot in terms of the job. Yeah, the best chance you will keep your job is learn how to design, engineer, yeah, and control programming a robot. So you can make sure you always stay ahead of the technology change. So this course became in November 2016 became the first course IoT or course in Australia created by Engineer Australia. Yeah, the panel, the course accreditation panel of Engineer Australia highly praised a feature or approach we use, so-called 3-in-1 in our course curriculum design. So by 3-in-1, we actually combine the three things together, yeah, into a package. So in our IoT course, we teach students both traditional electrical engineering and all the so-called hardware skills. And also we teach students, yeah, the software skill, programming, IT, etc. And more important, yeah. So you can see from this graph, yeah. So bottom layer, yeah, we teach traditional EE skills, and top layer we teach the student, yeah, the software programming. But very importantly, in the middle, we started very early on teaching students the skill of data analytics, statistics, and machine learning. Yeah, because we were trying to impart the student the knowledge. Yeah, so the IoT, the core part of IoT, it's about data analytics. It's about to turn the data into inside information and knowledge. So our work has raised a lot of attention in Australia. Yeah, So Australian Prime Minister Scott Morrison came up to the campus in early 2019. And I had the pleasure, your honor, to brief him face to face about the establishment of Australia's first IoT course. The Prime Minister was quite happy because when we told him, the country's first IoT course is running from Cairns in far north Queensland, rather than Melbourne, Sydney, So he was quite happy as a reward, and he announced a $30 million Cairns Innovation Centre. So the 30 million Cairns Innovation Center is meant to be a one-stop shop for the IoT discipline at James Cook University Cairns campus. So this is where we teach students, students have their normal classes, and also students having their hands-on practice. But a very, very important feature of this building is, it's served as an incubator. And also we have a so-called industry tennis. So that's where we want industry coming along into the building. They come with their technology, the problems. So we have the student working with them side by side. So if they're, working on the real world problems. This now later on renamed Ideas Lab, JCU's Ideas Lab, which we recently opened in early August 2020. The building itself is a smart building. And it's a very nice feature. I strongly encourage you to have a look online. And also the work, I led our team, to raise some other attention. I was invited by TED Forum to give a talk on IoT in 2018. So that's where I introduced this experience, but also talk about not only this course, but also how can we use the latest IoT technology to save the reef. And I'll be talking more details later on. And also some of our research work, get reported by ABC, Australian Broadcasting Corporation, which is the Australian national TV. The work we did is Internet of Things, rain gauge, and that can sit in your backyard, and send the climate data automatically to the cloud and analyze data. So this is very much welcomed by the farmers, and because they can use this piece of devices and generates a lot of data and to tell whether monitor the rainfall in their farm, so they can know when is the best time to irrigate their farm. And I left JCU mid of the year, in the middle of the pandemic. So I took up a position, the Cisco chair in AI and IoT, based at La Trobe University. The Cisco Research Chair program is an international elite research chair program, covering both US, Canada, and Australia. It's about a dozen Cisco chair around the world, and in Australia we have 3 of them. So myself as a Cisco chair in AI and IoT, my colleague Professor Chish Williams is a Cisco chair in digital healthcare. And also, very recently, Professor Riza joined Curtin University as a Cisco chair in advanced networking. He was based in UK previously. And in collaboration with Cisco, we built a Cisco Center for AI and IoT. And as far as I know, this is the first center within Cisco and also in Australia, dedicated to not only to some centers already existing in AI, and also some center already existing in AI IoT. But as far as I'm aware of, this is the first center in combining the strengths of both AI and IoT in Australia. So the theme of this center is so we advocate when we join AI and IoT, so we can release superpowers of innovation. So this center is meant to be the primary sponsor of the center is Cisco, but also we work with a lot of the industry partners working on the real world problems Yeah, Cisco has a range of the partners which work in the different vertical industry like mining, agriculture, asset management, etc. And also La Trobe University, we have different AI and IoT courses at the master level. Yeah, La Trobe University is based in the metropolitan area in Melbourne. So we have the arguably the largest metropolitan campus in Melbourne. It's huge, and it's only half an hour driving from the CBD of Melbourne. Yeah, so we have a very large cohort of international students. Yeah, and our campus is very multinational. And also the school I'm in, yeah, so we have specific 2 courses. Yeah, one's called a Master of AI, the other one is a Master of IoT. So both courses, are specifically targeted on these 2 areas. Then I'm going to use the Great Barrier Reef as an example to show how AI IoT technology can be used to save Great Barrier Reef, which is one of the greatest treasure on Earth, and arguably the only natural architect, yeah, that can be seen from the moon. So what is the Great Barrier Reef? Great Barrier Reef Marine Park is a vast area covering around 344,400 square kilometers. Yeah, stretching primarily the north and to Queensland of Australia to the very far north tip. Yeah, the reef is beautiful. Used to be very, very beautiful. Yeah, so you can see on this left-hand side, and that's what the healthy reef looks like. Yeah, but in the past few years, because climate change, like heat waves in the summer, and also a very poor quality water, and due to human activity and also farming activity, so reef has been severely damaged, causing what is bleaching phenomena on the right. So when the water is good, yeah, so you can see a reef provided very supporting environment for the reef to grow, healthy reef. But when the water is poor, yeah, primarily due to runoff from agriculture fields, yeah, that's going to have a huge impact on the health of the reef. So a challenging question is probably is how do we monitor the agricultural runoff and also human runoff, stop them from impact on the reef. We can't get rid of all the farming, along the far north, eastern, the North Australian, North Queensland coastal, because a lot of people are living off, farmers are living off those lands. They've been growing the cane sugars primarily, the main produce in the area for nearly 200 years. They live off them, so it's not reasonable, and also it's not economically feasible to get rid of all the farming. Yeah, so we have to learn how to using advanced technology to best preserve to promote the best farming practice, and in the meantime, preserving and improving the health condition of the Great Barrier Reef. Now, this is a real, because of James Cook University, this is part of work I did, when I was at JCU, and JCU's Cairns campus is right on the doorstep of the Great Barrier Reef. So we are highly specialized in using IoT technology for smart ocean. Yeah, this diagram is a conceptual diagram for smart ocean. Yeah, when it comes to smart ocean, it's all about using various different sensors, collecting data from the ocean, but also the communication plays a very, very important role, because we have to using, once we collect the data out in the ocean, the telecommunication infrastructure is very real. Yeah, so we have to use all possible means, like IoT of satellites, like drones, to get the data out of the sensors, ocean sensors. So the Internet of underwater things, goes hand by hand with big marine data. So we use the sensors, different types of sensors, marine sensors, collecting the data. Yeah, and we use advanced communication technology, which is very challenging because in the marine environment, yeah, power is an issue. Infrastructure, communication infrastructure is also a huge issue. So that makes the marine IoT arguably the most difficult vertical area of when you apply to IoT. Yeah. Because without the battery, yeah, so the sensors won't last for too long, and out in the ocean is very difficult, very cost you very much to replace the energy. So many times we have to rely on the solar panel. But the problem with the solar panel is that the ocean is very a rough environment. You got all kinds of different weather conditions, very harsh conditions, sometimes even cyclones. So that makes the energy collection it's so difficult, and as well as communication. Yeah. So, but nevertheless, once we collect the data and the big marine data, analytics kicks in. So this is where relatively easy. Once the data gets into the clouds, so we can use the conventional method. Yeah, that being used applied in other discipline, other vertical areas to analyze the marine data. And yeah, I want to talk about two examples projects we did. The first one is we did with a local farmer near in North Queensland. Yeah, the kangaroo sugarcane farmers. So previously I said, one of the biggest threats for the Great Barrier Reef is the agricultural runoff, because the main produce around this area is the sugarcane. To grow sugarcane, the farmers have to use a fertilizer, pesticide. Yeah. So the timing of applying this is very critical, because if you don't, apply them in a proper timing, say if you apply them, in the morning, and then suddenly there's a huge, because that area is a tropical area, so a lot of rain, and sandstorm, and they can wash the fertilizer and pesticide into the Great Barrier Reef lagoon, causing damage to the Great Barrier Reef. So what we are doing is to work with them, to plant the sensors into the farmland, into the paddock. So those sensors can automatically detect the soil moisture, humidity, weather condition, etc., and then automatically control the irrigation system. So this has a huge advantage. It not only just saves the water, because when we know it's going to rain, there's no point of watering the farmland, but also it saves the energy. But more important, it can improve the water quality, because we want to, if we prediction is accurate, we can fertilize and apply pesticides to the farmland when it's very dry, when there's no rain for a few days. So those pesticides and fertilizer will pretty much sit on the soil, deep into the soil, without being to wash into ocean straight away. So this is a classic example how the AIoT technology can be applied into digital agriculture, so that we can improve the outcome, both for farmers, because we save the water for them, we save the energy for them, but also we can achieve the desirable the environmental outcome. So another example is we did a project with the Kansas City Council. So rather than looking at the farming activities and impact, we're looking at the human activity. How the human waste around is going to affect the Great Barrier Reef. Cairns is a city relatively small size in terms of international student standards. It has a population of 150,000. It's the only big city. Relatively we call it big city. Along the far north Queensland. Another one is in northern Queensland is the Townsville. So there's a lot of the research has been done previously on how the farming practices affecting the Great Barrier Reef, but we were very proud. Yeah, back in 2019, yeah, this study funded by Australian government, the federal government, was the first one in the world to look into how human activity is impacting on the reef. So what we did is that we're working with Kansas Regional Council. We choose, a creek, yeah, that goes over, this central area of Cairns and washing into and flows into the Great Barrier Reef. We install a number of sensors, and put them in the gauge station, and to real-timely to monitor, how the Kansas City, the waste the city generates is impacting on the Great Barrier Reef. Yeah, so we not only built a hardware, the sensor collect the data, a gauging station, but also we made a dashboard, and we engage the concept of citizen science. So we open up to the whole world. So anyone, who is interested in saving the environment, who's interested in keep up the health of the Great Barrier Reef, can have a look. They can, this data is updating itself every 15 minutes, and we open the data to all over the world. So anyone can monitor the near real-time condition of the Great Barrier Reef and how the water quality is impacting on that. So based on our experience, both research, scientific research, as well as a project with local farmers, with the Kansas City Council, we realize that the marine IoT is one of the very, very challenging user scenario for application for IoT. The reason are two different reasons. Yeah, first one is the marine the sensors, particularly marine water quality sensors, very expensive. Yeah, some of them, for example, are nitrate on a nitrogen sensor. That cost you around $40,000 a piece. Yeah, but the Great Barrier Reef is it's a huge area. Like I previously said, it's covering an area of more than 344,400 square kilometers. So we're gonna have to use a lot of them. So that's a huge cost. So we have to come up with smart ideas to reduce the cost on the sensor. And also the sensors, because those marine sensors, when we deploy them in the marine environment, we can't expect to, we put sensors there, it will just automatically, work, reporting data, every fixed interval. That only works in the laboratory. Out in the field, the sensors strike, they don't report the data as regularly as we would expect it, or as we are configured, due to various reasons like maintenance, just malfunction sometimes. Yeah. So and also sometimes they might transmit the data, but we're just not receiving them. Yeah. So the data, missing data is very, very common in marine environments. So this is one of the most difficult challenges we have to deal with. Yeah. So the data we receive from the sensors are just incomplete. And also it's very expensive. And communication is also another big problem. Like I said, out in the ocean, the environment is very harsh. So we have to maintain the sensor, to keep powering the sensor. And also we have to, it's not feasible unless the sensor are placed very close to island. We can install the telecommunication infrastructure on the island. Otherwise, many times we have to using so-called low power IoT or satellite communication. So in this regard, we work with the Australian Institute of Marine Science and to try experimental on using the IoT over satellite. Yeah, so the AIMS is one of the leading scientific agency in marine research in the world. Yeah, so they partner with a Australian company called Miriata to send the data to the satellite. All right, so now coming back to research, scientific research, as I mentioned, yeah, one of the very, very challenging problem, yeah, when dealing with marine IoT is that there's a lot of the missing data, yeah, when we collect the sensors, the data from the sensors. So how do we deal with them? Yeah, one natural thinking is trying to using, higher end sensors, or trying to increase the frequency of maintenance of the sensors. But those are not just feasible. Yeah, the cost or simply cost too much. So our idea is we'll have to use machine learning for so-called IoT data imputation. So based on the well-known correlation, yeah, both we can do both the interpretation or extrapolation, yeah, when the IoT sensor data is missing. So this is where I would like to share with you one of our most recent work in dealing with multivariable time series data, and that's where we place a multiple number of marine sensors into a confined real environment. So I'll place those sensors are placed close to each other to collect a particular data, data from a particular area. So our idea is so-called, a very novel bi-directional recursive encoder-decoder network. So which are capable of not only just imputing missing multivariate time series data, but also can predict the future data for those multiple sensors. So this so-called bi-directional recursive encoded decoder network is obviously, as the name suggests, is an encoder-decoder structure. So they consider consisting of an encoder and the decoder. And also the output of this data is we achieving both data imputation, and that means filling the gap of missing data, and also prediction of the future data in a single network. Yeah, most other work have to use two separate networks for imputing data, one for imputing missing data, and one for predicting future data. But we are using a single network to do both. Yeah, so this is why you see from the top. So we have a multiple output. Right on top is we can do the imputation and also prediction. So at the bottom is it's an encoder. Yeah, the encoder consists of number of the components. It's called RNN and -2DCR. The 2DCR is one of the innovative methods makes this bi-directional recursive encoder-decoder network possible. We're going to talk about more details in the next slides very soon. But also, the network consists of a decoder, and also is bi-directional. Yeah, the decoder contains first working forwards and then backwards. The decoder contains INN traditional INN block, but also novel IB block, which stands for imputation block. So this is the block that tries to explore the internal correlation within the multivariate time series data, and trying to interpret the missing data. And by the way, the target here we are talking about is multivariate time series data, which means the multivariate stands for multiple variables. So we are talking about a number of sensors simultaneously collecting data, forming a single multivariate time series data stream. Now, because when we were designing this piece of work, and we come up with this novel idea, two-dimensional cross-regression module. Yeah, because it's a multivariate time series data. So those data are collected by multiple sensors, and also because those sensors are placed approximately close to each other in terms of physical location. So it's natural to assume there's a strong correlation in between. Previously, in time series data, data imputation for time series data, and correlation is only explored between in the time domain. Yeah, because for single sensory data, single variable, yeah, the past values has a strong influence on the future values. But when we have both, multiple sensors placed close to each other, so those correlation, can happen in 2 dimensions. Yeah, both the time dimension and the sensor dimension. Yeah, so this is why. Yeah, so we named it as cross regression. So we are exploring the correlation in both dimensions. So you can see from the top left figure, so time dimension is horizontal, and vertical dimension is sensor dimension. So we can say, the red cross means the data is lost. So we come up with a model, and is parameters. So we can use the correlation across both time and the sensors to predict for better prediction results. And also, previously we said the imputation block is able to explore this this internal correlation. So it turned out, just cautious for time. Yeah, it turned out the results very good. Yeah, we compared to a number of very recent work. Some of them very published in the very high ranking journals like IEEE transaction on cybernetics, and one published by PAMI. Yeah, and turns out we tried our data, the performance of our networks on 3 different data sets, the feature net and MIC 3 data set, which is medical data set, and the last one is appliance energy, is the energy data set. So this is a result. On the left-hand side, we show all the comparison algorithm, the performance, their MAE, specifically their MAE performance on 3 different data sets. They're coming from different vertical industry and shows very good results. Our proposed bi-directional encoder-decoder networks can beat all of them. And then we choose, on the right-hand side, we choose a specific, the last, looking into the last applies energy data set. And then we use some other, performance variables, evaluation matrix like AUC, RMSE, and we look into the gain, So once again, it shows the performance of the proposed bi-directional encoder and decoder network, outperforming all the others. And we summarize the advantage of our proposed work. So first of all, it's a single network which can, do both data imputation, filling the missing data, but also can predicting the future data as well. And secondly, we come up with this novel idea of exploring the cross regression, across correlation, for 2 dimensions, time domain and the sensor domain. And our future work, we are going to expanding this to 3-dimensional. So in the future, we're considering a so-called a space domain. So that's where the sensors are placed multiple, relatively not so close to each other. So they're forming a grid in the space. So that's where you have time, you have a sensor, and then you have a space domain into play. So that makes the data imputation prediction task much more challenging and the modeling much more complex. But I think that's a very interesting piece of work. Looking forward to share that with you, hopefully soon. And that's all my talk. Thank you very much for listening. And if you want to have a discussion, I very much welcome you ask me a question. And you can straight send my email, and you can Google my name, at latrobe.edu.au. Thank you again.